Good evening. Today we are going to see stress-strain relationship in 3 dimensions. Bodies with forces in 3 dimensions. Now you can have this Civil Engineering Technical Hub. This is my YouTube channel. And if you will go in this YouTube channel, then you can see you have playlist in that one. So you have videos, live playlist. So in playlist, if you will press this playlist, then you will come with different playlist. And in this playlist, you will come across different subjects. So here you can see this. We have finite element method. Then we have end sem exam. So these videos are prepared for the examination. End sem examination for SPPU. These are for in sem examination. So these are the different videos. You can go through it and you can see, and you can have questions on this. So now we will go with 3D stress-strain relationship. So before going to this, you can subscribe this channel so that you can get the updation of the new videos. So now we have stress. The stress we know, which is resistance upon area. The stress component in 3D body are normal stresses in XYZ direction, because the stresses which are perpendicular to the plane we are going to say as normal stresses, and the stresses which are in the plane we are going to say it as shear stresses. So we have 3 shear stresses and we have 3 normal stresses. So if we will draw a body, so if I will draw it, so we have, this will be a 3-dimensional body. And if we will apply low force stresses, I can say, so force upon area, we will get it as a stress. So we are being with this, we have this will be XX, we have this will be YY, and we have this will be ZZ. So along this axis, if I will apply force on this plane, so this will give me sigma X. On this plane, I will get sigma Y. And on this plane, I will get sigma Z. Now we are going to get 2 stresses, that is shear stresses in this plane. So it will be sigma XY. And then we have second will be sigma XZ. So along this, we will get sigma XZ. And along this, I will get sigma XY. So these 2 are shear stresses in the plane, and this sigma X, we are going to be with normal stress. Similarly, here also you will get sigma YZ and sigma YX. And here also you will get 2, that one will be, so this is sigma Z actually along this axis. So this is actually along this axis. And then 2 we will get, one will be sigma ZX and another will be sigma ZY. So likewise, we have in the plane shear stresses, perpendicular plane normal stresses. And accompanying these stresses, so we have 6 strains. So you can see this. So strain components corresponding to opposite stress components are given below. So 3 we have normal strains and 3 we have shear strains. So along X, we are going to be with epsilon X, Y, Z, along X, Y, Z. And again, just I have explained this, we are in this fashion. So now we have to keep in mind, we have gamma XY, that is equal to gamma YX. In the same fashion, here also we have tau XY is equal to tau YX. And therefore, though you are going to see this here, we have 6 shear stresses, but we have these will be equal. And therefore, we have 3 only over here. So now strain displacement relationship, we are going to consider only linear part, that is first order only of the term of strain relation or strain equation. And that we will get it as epsilon X equal to W by WX. This will be normal strain, I can say. And then we have shear strain, we will get it as gamma XY is equal to W by WX, W by WY. Now we have to keep in mind U, V, and W. These are displacements along X, Y, and Z direction. So we have displacements along x, y, and z direction, x, y, and z directions. And then accordingly, so shear, so we are going to be v with x, u with y, whereas here u with x, because these are normal. Similarly, we can write these also, that is epsilon y, epsilon z, gamma yz, and gamma xz. So now we have shear strengths also. So sorry, shear strengths also we have mentioned here. So 3 shear strengths and 3 normal strengths. Now we have stress strain relationship. Now displacement I will not mention over here. So I will better mention that is stress strain relationship. And we have this will be for orthotropic material, means we have properties that is same along all directions. Now epsilon x, we have sigma x by E. So this will be my normal strain. This will be normal, or I can say better linear strain. And then this we are going to be, that is minus sign also I can mention it. And this will be my lateral strain. We know lateral strain into mu, sorry, linear strain into mu is lateral strain, because we have Poisson's ratio. If you remember, we have Poisson's ratio that is equal to lateral strain upon linear strain. And from this, we are going to get these values, because we have linear strain, we have sigma x by E, then we have sigma y by E, and then we have sigma z by E. Now, what is lateral strain, linear strain? You can go to competitive lecture number 1 in this, or you can have that strength of material playlist, and in that one, if you will go to the first video, you will come to know this. Similarly, I can write epsilon y, epsilon z, and I can write shear strength also, which is tau xy upon g, because we know stress equal to strain into g, that is modulus of rigidity. Here we can say shear modulus, because we have this as a shear plane. Similarly, I can write gamma yz and gamma zx. Now we are interested to prepare a relationship between stress and strain. And now if we will see this one, we have to prepare, this will be sigma x, sigma y, sigma z, tau xy, tau yz, and tau xz. And we have some matrix, and then we are here, that is strengths, epsilon x, epsilon y, epsilon z. Then we have gamma xy, gamma yz, and gamma xz. So we are interested to find this D matrix. So we have to find equation sigma x, sigma y, sigma z. Actually, tau xy, tau yz, and tau zx we can be very easily from here. So now we have this equation 1, 2, 3. So we will add these 3 equations. And by adding, so I will write adding equations 1, 2, and 3. So adding equations 1, 2, and 3. And from this, what we will get, so just you can see, I will simplify a little bit. E into epsilon x plus epsilon y plus epsilon z, and that is equal to, now try to understand this. So now I have taken E towards the left, because we have denominator E for all. And now you can see we have sigma x by E here minus mu sigma x by E minus mu sigma x by E. So what I will get, sigma x by E minus mu sigma x by E minus mu sigma x by E. If we will take sigma x by E common, then we will get 1 minus mu, and from this we will get sigma x by E 1 minus 2 mu. Similarly for sigma y, similarly for sigma z. Now E already we have taken on left, so we will get only sigma x 1 minus 2 mu. So if I will consider for all, then I will get it as sigma x plus sigma y plus sigma z, and that is in bracket 1 minus 2 mu. Now we will go to equation 1, and in equation 1 I will have epsilon x equal to sigma x by E minus mu sigma y by E minus mu sigma z by E. And now we know we have to find equation in terms of sigma x, so I have to replace sigma y by z by sigma x and all these strains. And if we will see this, then we have E into epsilon x, this is equal to sigma x minus mu in bracket sigma y plus sigma z. Now if we will take sigma x by sigma z on this side, I will get mu in bracket sigma x plus sigma y, that is equal to sigma x minus E into epsilon x. Now if I will take mu on this side, then we will get this as sigma y plus sigma z. So we have sigma y plus sigma z. So we will get it as sigma y plus sigma z, which will be equal to sigma x minus E epsilon x divided by mu. And now we will put this value. If I will mention this as equation 4, so I have to substitute this value in equation 4, sigma y plus sigma z. And from this, if I will take 1 minus 2 mu on left side, then I will get it as E epsilon x upon 1 minus 2 mu plus E epsilon y upon 1 minus 2 mu plus E epsilon z upon 1 minus 2 mu, and that is equal to sigma x plus, now sigma x upon mu. Now I am going to substitute sigma y plus sigma z. So I will get sigma x upon mu minus E epsilon x upon mu. Now I will rearrange the terms, or I will take mu, this will be denominator, and from this what we will get, so we will get it as mu E epsilon x upon 1 minus 2 mu plus mu epsilon y upon 1 minus 2 mu plus E epsilon z upon 1 minus 2 mu. Now I will get this plus, I will take this on this side, E epsilon x upon mu, and that is equal to, if I will take sigma x in this, then I will get mu plus 1 upon mu. Now if we will take mu on this, we will have already taken mu on this side because we have multiplied it by mu. So I will cancel this mu now over here. Means what we have done over here. So if I will go one step over here, so we have sigma x, mu sigma x plus sigma x minus E epsilon x, and I have kept this mu as it is. So actually we do not have mu here also, or we can have this, we have to multiply here also by mu, and this mu gets cancelled. So we do not have mu over here. So this I will directly take minus E epsilon x as plus E epsilon x on this side. Now if I will take E epsilon x common, then I will get E epsilon x in bracket. Now you can see here we will have mu, and then we will have here, that is 1 minus 2 mu. So I have plus 1 minus 2 mu. Then we have plus, now I will take 1 minus 2 mu common. So mu epsilon y plus mu E epsilon y plus, here also mu that was forgot. So mu E epsilon z, and then we have upon 1 minus 2 mu. And if you will solve, I will first solve this. So mu minus 2 mu. So I will get it as, if I will take E outside, E upon 1 minus 2 mu, and that is in bracket, we have, in first I will get 1 minus mu epsilon x plus mu epsilon y plus mu epsilon z, and that is equal to 1 plus mu into sigma x. If I will take sigma x on this side, 1 plus mu on this side, then I will get equation as sigma x equal to E divided by 1 minus 2 mu in bracket 1 plus mu in bracket 1 minus mu epsilon x plus mu epsilon y plus mu epsilon z. Similarly, we can write it for sigma y also and sigma z also. So what I will get, sigma y is equal to E upon 1 minus 2 mu in bracket 1 plus mu into 1 minus mu sigma y plus mu sigma x plus mu, mu epsilon y, mu epsilon x, and mu epsilon z. And similarly, for sigma z, we have E upon 1 minus 2 mu, 1 plus mu into 1 minus mu epsilon z plus mu epsilon x plus mu epsilon y. Now, these are for normal stresses. For shear stress, I have tau xy that is equal to G into gamma xy. Now we have G E upon 2 in bracket 1 plus mu into gamma xy. But as we have to go for common, so just if we will see over here, we have tau xy and D. Now in D, if we will see, we have denominator is this. So we have to make denominator over here in the same way. So I have to multiply it by 1 minus 2 mu, also divided by 1 minus 2 mu into 1 plus mu. That is into gamma xy. And now we can write it in this fashion. E upon 1 minus 2 mu, 1 plus mu. And I can write in another bracket, that is 1 minus 2 mu upon 2 into gamma xy. Now if we will go to tau xy and if we will go to tau xy and then tau yz, then we have tau xy is equal to E upon 1 minus 2 mu in bracket 1 plus mu into 1 minus 2 mu, this is yz, 1 minus 2 mu upon 2 into gamma yz. And similarly, for tau yz, I will have this as E upon 1 minus 2 mu, 1 plus mu, and into 1 minus 2 mu upon 2 into, this is gamma zx, gamma zx. So into gamma zx. So this is tau xy, tau yz, and this is tau xz or zx, one and the same. And then likewise, we are going to get this equation. And then from this, we can see we have E upon 1 minus 2 mu, 1 plus mu outside. So we have taken, now I have prepared this, E upon 1 plus mu, 1 minus 2 mu. And then you can see this, for epsilon x, we have 1 minus mu, epsilon y, mu, epsilon z, mu. And then others we have 0, shear strain. So we have prepared this matrix by using this. And in shear, we have seen 1 minus 2 mu upon 2. And likewise, we have, this will be shear stress-strain relationship in 3 dimensions. So likewise, we have to derive this. So if you like this video, please like and subscribe channel, Engineers Technical, Civil Engineers Technical Hub. So we have actually this name that was changed, and it is Civil Engineers Technical Hub. Civil Engineers Technical Hub. So now subscribe this channel and like the video. If you have gone through video, then like it. So now we will stop here only. So remaining part we will see in the next lecture. Thank you.